Biology 5.2 Threats to our biodiversity. Some human activities reduce biodiversity in ecosystems, and current evidence suggests that reduced biodiversity might have serious long-term effects on the biosphere. And unfortunately, we don't know what a lot of those effects are until much, much later. So our essential questions for this section: what are the threats to biodiversity? How is the current extinction rate different from the background extinction rate? And how can the decline of a single species affect an entire ecosystem? The gradual process of species becoming extinct is known as background extinction. Scientists are not concerned about the natural process of extinction as much as the increasing rate of extinctions. Mass extinction is an event in which a large percentage of all living species become extinct in a relatively short period of time. Take a look at this chart here by pausing the video, or you can reference your book at another time.
The Earth has undergone numerous mass extinctions since the first bacterial life evolved about 3 billion years ago, and we are facing a potential 11th extinction as global warming threatens to disrupt our planet's ecosystems. In this video we count down the 5 biggest Earth mass extinctions. The KT extinction was a global extinction event responsible for eliminating approximately 80% of all species of animals about 66 million years ago. The KT extinction was characterized by the elimination of many lines of animals that were important elements of the Mesozoic era, including nearly all of the dinosaurs and marine invertebrates. Many theories have been offered over the years to explain dinosaur extinction, but only a few have received serious consideration. The extermination of the dinosaurs has been a puzzle to paleontologists, geologists, and biologists for 2 centuries. Proposed causes include disease, heat waves, freezing cold spells, the rise of egg-eating mammals, and X-rays from a nearby exploding supernova. Since the early 1980s, however, much attention has been focused on the so-called Asteroid Theory, formulated by American scientists Walter Alvarez and Luis Alvarez. This theory states that a meteorite impact may have triggered the extinction event by ejecting a huge quantity of rock debris into the atmosphere, enshrouding the Earth in darkness for several months or longer. With no sunlight able to penetrate this global dust cloud, photosynthesis ceased, resulting in the death of green plants and the disruption of the food chain. The Ordovician Extinction actually comprised 2 separate extinctions, one occurring 447 million years ago and the other 443 million years ago. By the time these 2 pulses were over, the world's population of marine invertebrates, including the brachiopods and corals, had declined by a whopping 60%. The cause of the extinction is still a mystery. Candidates range from a nearby supernova explosion which would have exposed the Earth to fatal gamma rays, to the release of toxic metals from the seafloor. The Cambrian extinction event occurred approximately 488 million years ago. This early extinction event eliminated many marine species and severely reduced the number of trilobite species. The middle of the Cambrian period began with an extinction event. One hypothesis suggests that this was due to temporary depletion of oxygen, caused by an upwelling of colder water from deep ocean areas. The upwelling eventually resulted in a variety of marine environments ranging from the deep ocean to the shallow coastal zones. Scientists theorize that this increase in available ecological niches set the stage for the abrupt radiation in life forms commonly called the Cambrian explosion. The Snowball Earth hypothesis proposes that Earth's surface became entirely or nearly entirely frozen at least once, sometime earlier than 650 million years ago. Proponents of this hypothesis argue that it best explains sedimentary deposits regarded as of glacial origin at tropical paleoaltitudes, and other features in geological record. Opponents of this hypothesis contest the implications of the geological evidence for global glaciation, and the feasibility of an ice or slush-covered ocean, and emphasize the difficulty of escaping an all-frozen condition. While the geological evidence for Snowball Earth is strong, its cause is hotly disputed. The possible candidates ranging from volcanic eruptions to solar flares to a mysterious fluctuation in Earth's orbit. Assuming it actually happened, Snowball Earth may be when life on our planets came closest to complete extinction. A major turning point in the history of life occurred 2.5 billion years ago, when bacteria evolved the ability to photosynthesize. That is, to use sunlight to split carbon dioxide and release energy. Unfortunately, the major byproduct of photosynthesis is oxygen, which was toxic to the anaerobic organisms that appeared on Earth as far back as 3.5 billion years ago. 200 million years after the evolution of photosynthesis, enough oxygen had built up in the atmosphere to render most of the Earth's anaerobic life extinct.
The current high rate of extinction is due to the activities of a single species, Homo sapiens, that's you and me. Humans are changing conditions on Earth faster than new traits can evolve. Natural resources are the materials and organisms found in the biosphere, including minerals, fossil fuels, nuclear fuels, plants, animals, soil, clean water, clean air, and solar energy. One factor that contributes to the rising extinction rate is the overexploitation or excessive use of species that have economic value. Some of those species are bison, passenger pigeons, ocelot, and rhinoceros. Destruction of habitats such as clearing tropical rainforests has a direct impact on global biodiversity. Disruption of habitats such as overfishing can start a chain reaction and affect an entire ecosystem. The separation of an ecosystem into small pieces of land is called a habitat fragmentation. Here we have a patch of habitat. More edges in the habitat increases the percentage of the patch that is edge habitat. There are some problems with fragmentation. Smaller parcels of land support fewer species, reduces the opportunities for individuals in one area to reproduce with individuals from another area, decreases genetic diversity, and creates more edges. Edge effects are different environmental conditions experienced at the boundaries of ecosystems. Pollution changes the composition of air, soil, and water. Biological magnification is the increasing concentration of toxic substances in organisms as trophic levels increase in a food chain or food web. Acid precipitation. Sulfur and nitrogen compounds react with water and other substances in the air to form sulfuric acid and nitric acid. Acid precipitation removes calcium, potassium, and other nutrients from the soil, depriving plants of these nutrients, therefore depriving you and me of the nutrients as well. Water quality is something that we do worry about as environmentalists and scientists when it comes to our population and huge factors that threaten our biodiversity. Eutrophication occurs when substances rich in nitrogen and phosphorus, like fertilizers from farmers, flow into waterways, causing extensive algae growth. The algae use up the oxygen supply during their rapid growth and after their deaths during the decaying process. Other organisms in the water suffocate. Non-native species or invasive species that are either intentionally or unintentionally transported to a new habitat are known as introduced species. Introduced species often reproduce in large numbers because of a lack of predators. An estimated 40% of the extinctions that have occurred since 1750 are a result of introduced species.